Hello students, myself Kale SL, Rayat Shikshan Sanstha's RBNB College Rampur. 11 Science Mathematics Part 2, Lecture number 7, Chapter number 1, Complex Numbers, Exercise 1.3. In the previous lecture, we have seen basic concept of Argand diagram or complex plane. Also, we have seen modulus of complex number, argument of complex number, polar form of complex number, and exponential form. That is, if z is equal to a plus ib, z is equal to a plus ib, then we find its modulus as mod of z is equal to under root of a square plus b square, and we denote it by r. Suppose r is equal to mod of z is equal to under root of a square plus b square. Also here we find theta is equal to tan inverse of b upon a. This r and theta, these are called the polar coordinates of the point P, which represent the complex number z in the complex plane. Also we have seen here polar form, that is z is equal to a plus ib. This complex number we write in polar forms as r in the bracket cos theta plus I sin theta. This is the polar form, and r e to the power I theta, this is the exponential form. We have seen this. This is the complex number z is equal to a plus ib. We write in terms of polar form, that is r and theta, that is r in the bracket cos theta plus I sin theta, and z is equal to r into e to the power I theta. This is the exponential form. This is we have seen in the last video lecture. And also we have completed some problems of question number 1st, and we continue the next problem. We continue here question number 1st. Find the modulus and amplitude for each of the following complex numbers. Problem number here 7th, we have given 3. So we call here it as z is equal to 3. We write this 3 as 3 plus 0i. 3 plus 0i. So it is equal to we compare with a plus bi, and therefore we get here a is equal to 3, a is equal to 3, b is equal to 0. Now find here mod of z. So mod of z is equal to under root of, we have a square plus b square. So it is equal to under root of, put a as a 3, so 3 square plus b as a 0 square, and so it is equal to 3 square, that is 9, and 0 square is 0. So it is equal to under root of 9. So mod of z is equal to square root of 9 is 3. So magnitude of this complex number is 3. Now we want to find amplitude of z is given by theta is equal to tan inverse of b upon a. We use this formula, theta is equal to tan inverse of b upon a. So it is equal to tan inverse of, now put the value of b here 0 upon a, and 0 upon a, any 0 upon anything that is equal to 0. That means here a tan inverse of 0, and so we get theta is equal to, now 0 is the value for which angle, that is tan 0 is 0, and therefore here 0 value for tan of theta, tan of 0 degree. So here theta is equal to 0. So in this way we get theta and mod of z as root 3. This is the solution of the 7th problem. Next here 8th and 9th problem solve yourself. I take here last problem, 10th problem. 10th problem. 1 plus 2i bracket square 1 plus 2i bracket square into 1 minus I. So we consider this as z. So let here z is equal to 1 plus 2i bracket square into 1 minus I. Firstly we solve this problem and we convert it into a plus bi form, that is real part plus imaginary part. So we expand this 1 plus 2i bracket square using the formula a plus b bracket square. So it is equal to a square means 1 square, that is 1 square is 1, plus twice a into b means twice 1 into 2i. So 2 to the 4, so it is 4i, plus b square means 2i square. Here 2 square is 4 and I square is I square. And this second bracket 1 minus I as it is. And so it is equal to this 1 plus 4i. Now here we know I square is minus 1. So 4 into minus 1 and this 1 minus I as it is. And now it is equal to this 1 and plus minus 4. So 1 minus 4, 1 minus 4 that is minus 3. We write here minus 3. This 1 plus minus minus, so minus 4. 1 minus 4, it is minus 3 plus 4i into this 1 minus I. Now take the product of these two brackets. So it is equal to, firstly we multiply by 1. So 1 into minus 3, it is minus 3. Plus 1 into 4i, 4i. Now multiply by minus I into minus 3, it is plus 3i. And then minus I into plus 4i, minus into plus it is minus, 4i into I, that is 4i square. So we get here this minus 3 as it is, plus 4i plus 3i, it is 7i. So plus 7i, 4 plus 3, 7, so 7i. And minus 4, and we know the value of I square is minus 1. So we get here this minus 3 as it is, plus 7i, and minus minus become plus, plus 4. So minus 3 plus 4, this is the real number or real part. We add this minus 3 plus 4 or 4 minus 3. 4 minus 3 is 1. So it is equal to 1 plus 7i. We get here 1 plus 7i, and we compare with a plus bi. This is Z. So we get A as a 1 and B as a 7. Therefore, A is equal to 1 and here A real part is 1 and B is 7. B is equal to 7. Now we want to find mod of Z. So mod of Z is equal to, we have the formula under root of A square plus B square. And so it is equal to under root of, put the value of A as 1 square, B as a 7, that is 7 square. So it is equal to 1 square is 1 plus 7 square is 49. 49 plus 1, that is root of 50. We write this root of 50 as 25 to the 25 to the 50, because we know the square root of 25, and so square root of 25 is 5 root 2. So mod of Z is 5 root 2. Now we want to find theta. Amplitude is given by, amplitude is given by theta is equal to, we use the formula tan inverse of B upon A. Here point is 1, 7. A is 1 and B is 7. So the point 1, 7, the point 1, 7, both are positive, plus and plus. So plus plus, it is in the first quadrant. So the point 1, 7 lies in the first quadrant. Lies in first quadrant, and therefore since this point lies in the first quadrant, angle should be in the first quadrant. Therefore theta is equal to tan inverse of, put the value of B as a 7 divided by A as 1. That means theta is equal to tan inverse of 7. But 7 is not the standard value in the table of tan. In the table of tan there is 0, 1 upon root 3, 1, root 3, infinity. These are the standard values for the standard angle, that is 0 for 0, it is 0 for 30, 1 upon root 3 for 45, 1 for 60 degree root 3 for 90 degree infinity. These are the standard angles. So this value is not standard, so put it as it is. So this is the solution. Theta is tan inverse of 7 and mod Z is 5 into root of 5. So in this way we have completed here 10th problem, and also we have completed question number first. Now here question number second is find the real value of theta. Question second, find the real value of theta for which 4 plus 3i sin theta 4 plus 3i sin theta divided by 1 minus 2i sin theta 1 minus 2i sin theta is purely real. It is purely real. So we have to find the value of theta, that is amplitude, for which 4 plus 3i sin theta divided by 1 minus 2i sin theta is a purely real, means this complex number is a purely real number. So see solution. We consider z is equal to, let z is equal to 4 plus 3i sin theta divided by 1 minus 2i sin theta. Get it? Now here if we observe the right hand side, numerator upon denominator, that is complex number divided by complex number. So when we take the division of two complex number, we remove the complex number from the denominator. So we take here, how to remove this? We take here conjugate of the denominator, means we change the sign of imaginary number and multiply to numerator and denominator. So put this as it is, 4 plus 3i sin theta divided by 1 minus 2i sin theta as it is. Now take the conjugate of denominator, means change here sign, instead of minus we take plus and multiply to numerator and denominator. So 1 plus 2i sin theta divided by here 1 plus 2i sin theta. So it is equal to, now we take the product of numerator divided by product of denominator. So multiply by 4 to this and plus 3i sin theta to this. So 4 into 1, that is 4, plus 4 into 2i sin theta. So 4 2s are 8i sin theta. Then multiply by 3i sin theta. 3i sin theta into 1, so plus 3i sin theta. Then multiply by this 3i sin theta to 2i sin theta. So 3 2s are 6. 3 2s are 6. I into I, that is I square. And sin theta into sin theta, that is sin square theta. Sin square theta divided by, now take the product of denominator. Observe here denominator are the complex conjugate of each other. So here first term is same, second term is same, here minus plus, so we use always a minus b into a plus b. A minus b, a plus b, a minus b into a plus b. It is equal to a square minus b square. We know this formula. So a is here 1, so 1 square minus b square. B means 2i sin theta. Take its square. 2 square, that is 4. I square and sin square theta. Using the formula a square minus b square. So we get here 4 as it is. This 8i sin theta plus 3i sin theta. That means 8 plus 3. That is 11. So 11i sin theta. 8 plus 3, 11i sin theta. Plus here 6 as it is. This I square is minus 1 into sin square theta. Into sin square theta divided by this 1 as it is, minus sign, then 4, here I square is minus 1 and sin square theta as it is. So we get 4, this plus and minus, 6 sin square theta. So this minus 6 sin square theta is real, and this real we collect these terms. So 4 minus 6 sin square theta. 4 minus 6 sin square theta. This is the real part. Plus here 11i sin theta. 11i sin theta. Divided by 1 minus and minus plus, so 1 plus 4 sine square theta. 1 plus 4 sine square theta. So we divide this 1 plus 4 sine square theta to this real part and this imaginary part separately. So what we get here? So z is equal to 4 minus 6 sine square theta divided by 1 plus 4 sine square theta plus 11 sine theta upon 1 plus 4 sine square theta into this I. Now observe here, this is a complex number, we call this as A, this as B, A plus BI, A plus BI. So now we have given this is a purely real. This is purely real means imaginary part is 0. When if this part is 0, then it is a purely real number. Purely real means that complex number does not contain the term of I. So since Z is purely real, Z is purely real, therefore imaginary part of this Z is equal to 0. And this is the imaginary part, coefficient of I, that is 11 sine theta divided by, therefore 11 sine theta divided by 1 plus 4 sine square theta, it should be 0, then this Z is purely real. Now carry this on the right hand side. So we get here 11 sine theta is equal to 0 into this, so it becomes 0, and therefore sine theta is equal to 0. Sine theta, it is equal to 0. Now see, sine theta is 0. We have to find the theta where sine is 0. If we consider here positive x-axis and this is positive y-axis, and we know that on the x-axis y coordinate is 0. On the x-axis y coordinate is 0, and we know that sine theta is nothing but the y coordinate. So theta is 0. This sine theta is 0 on the x-axis. So here when theta is 0, sine is 0. When theta is pi, here pi, then also sine is 0. When theta is 2 pi, then also sine 0. Then here 3 pi, it is 0. 4 pi, 0. Means here sine of n theta is equal to 0. Sine of n theta, sine of theta is equal to 0. This implies that theta is equal to n pi. We take n belongs to here z. If we take here n0, so sine of 0 is 0. Then put n as 1, so sine of pi also 0, sine of pi. N as 2, sine of 2 pi, it is also 0, because on the x-axis y is 0, y coordinate is 0, means the sine ratio is 0. So here theta should be n pi, n belongs to 0. This is the value of theta. So in this way we have completed here second problem. Now third problem here, if z is equal to, third problem, if z is equal to 3 plus 5i, then represent 3 plus 5i, then represent z bar minus z bar minus z bar in Argand diagram. In Argand diagram. Now we have given here z as z is equal to 3 plus 5i. Z as 3 plus 5i. It is represented by the point in the complex plane. That point is suppose a of real part is here 3 and imaginary part is here 5. So a of 3, 5. So we represent a of 3, 5 in the Argand diagram, which denotes the complex number 3 plus 5i. Now here z bar means conjugate of this z. So it is equal to 3 minus 5i. Conjugate. Imaginary number, we change the sign of imaginary number. And represent this by the point suppose b of real number, real part is here 3 and imaginary part is minus 5. So b of 3 minus 5 represent the complex number. Z bar is equal to 3 minus 5i. Then minus z. Minus z is equal to, here z is equal to 3 plus 5i. Multiply by minus. So minus z is equal to minus 3 minus 5i. So it is represented by the point suppose C, this minus 3 and this minus 5. Next minus z bar. This is z bar. Multiply by minus. So minus z bar is equal to minus 3 and minus minus plus 5i. It represents the point suppose D and real number is, real part is minus 3 and imaginary part is plus 5. So a of 3, 5, b of 3 minus 5 and c of minus 3 minus 5, d of minus 3, 5 represent the complex number z, z bar, minus z and minus z bar respectively. Now we denote these points in the Argand diagram like this. We construct here x-axis and y-axis. We call x-axis as a real axis and y-axis as a imaginary axis. Suppose this is the y-axis and this one is x-axis. Here 0 or we call it as O. Here 1, 2, 3, 4 and 5 suppose. Here also 1, 2, 3, 4 and 5 suppose. Here minus 1, minus 2, minus 3, minus 4 and minus 5. Here minus 1, minus 2, minus 3, minus 4, minus 5. Get it? Now first point here, a of 3, 5. Plus plus, both coordinate are plus, it lies in the first quadrant. In the first quadrant 3 and 5, x coordinate is 3, y coordinate is 5, here 3 and here 5. So this point is a of 3, 5. A of 3, 5. Now second point, b of 3 minus 5. X coordinate is positive 3 and y coordinate is minus 5. This minus 5. So here minus 5 and here this plus 3. This point is B. B of 3 and minus 5. It lies in which quadrant? Fourth quadrant. This is the first quadrant, second, third and fourth. Now C point, minus 3 minus 5. X coordinate minus 3, y coordinate minus 5. So here, suppose here C of, and here this point is C of minus 3 minus 5, and last D of minus 3, 5. X coordinate minus 3, y coordinate plus 5. Here plus 5, here minus 3 and here plus 5. So this point is D of minus 3, 5. So in this way we represent z, z bar minus z bar in the Argand diagram. These points A, B, C, D represents the corresponding complex number. This is the solution of this third problem. Now here fourth problem, express the following. Express the following complex number. Fourth problem, express the following complex numbers in polar form and exponential form. In polar form and exponential form. First problem here, minus 1 plus root 3i. Minus 1 plus root 3i. Firstly, we call this as z. So z is equal to minus 1 plus root 3i. Now we have to express this complex number in polar form. We know polar form, that is z is equal to r in the bracket cos theta plus I sin theta. We have seen in the last lecture. And in exponential form, r z is equal to r into e to the power I theta. We have seen this. Above one is the polar form and this one is the exponential form. So firstly we want to find r and theta. Okay, then we can write polar form and exponential form. So we compare this to a plus bi. So we find mod of z. Mod of z is nothing but r. R is the distance of the point P from the origin, length of OP. That is also denoted by mod of z, modulus. So it is equal to under root of a square plus b square. So it is equal to under root of, put the value of a. Here write a as a is equal to minus 1 and b is equal to root of 3. A real part and b is imaginary part. So a minus 1. So minus 1 square plus b as a root 3. So root 3 square. So it is equal to minus 1 square, that is plus 1, and root 3 square, root and square get cancelled. So it is 3. So under root of 4. And so it is equal to 2. So we get here mod of z as 2, that is r is equal to 2. We get here r as 2. Now we want to find theta. So theta is equal to theta, that is amplitude, or we may call it as an argument of complex number z. So theta is equal to tan inverse of b upon a. And now write down where the point lies, in which quadrant the point lies. Here point is minus 1 root 3. Point minus 1 root 3 means x coordinate is minus and y coordinate is plus. It lies in which quadrant? Second quadrant. Therefore point minus 1 root 3 lies in second quadrant. Why we write this? Because angle should be in the second quadrant. So theta is equal to tan inverse of, put the value of b as root 3 divided by a, that is minus 1. So theta is equal to tan inverse of root 3 upon minus 1, that is root 3. So carry this tan inverse to the left side, we get tan theta. So tan theta is equal to minus root 3. Tan theta is equal to minus root 3. Now root 3, forget this minus sign. Root 3 is the value for tan of which angle? Tan of 0, 0. Tan of 30 degree, 1 upon root 3. Tan of 45 degree, 1. Tan of 60 degree, root 3. So 60 degree. 60 degree means in the radian it is pi by 3. So tan theta is equal to minus tan of 60 degree means pi by 3. But see here, on the left side it is plus and on the right side it is minus. So we have to remove this minus sign. And since this point lies in which quadrant? Second quadrant. Point lies in this second quadrant. So the angle is in the second quadrant. So it is less than 180. 180 means pi. It is less than pi. How less? Here pi by 3. So when we want to remove this minus sign, we write this: tan of theta is equal to tan of pi minus this angle, pi by 3. This is the formula. Tan of 180 minus theta, that is minus tan theta. This is the formula. But here, to remove this minus sign, considering this point lies in the second quadrant, and second quadrant it is pi minus, third quadrant pi plus. Okay, so pi minus which angle? This pi by 3. And now here this negative sign absorb in this formula. So tan and tan get cancelled. So theta is equal to, we get here theta is equal to pi minus pi by 3. Pi minus pi by 3. So theta is equal to 3 pi minus pi upon 3. So theta is equal to 3 pi minus pi, that is 2 pi upon 3. Theta is 2 pi upon 3. In this way we get here r as a 2 and theta as 2 pi by 3. Therefore polar form of Z is given by Z is equal to r in the bracket cos theta plus I sin theta. So it is equal to, put the value of r as r2 in the bracket cos of theta. Theta is 2 pi by 3 plus I sin of theta, here also 2 pi by 3. This is the polar form. We have to write in polar form only. And the exponential form is Z is equal to r into e to the power I theta. Put the value of r and theta only. So Z is equal to r is 2, e to the power I, theta is 2 pi by 3. So write here like this, 2 into e to the power, firstly write this angle 2 pi by 3 and I. This is the exponential form and this is polar form. Get it? So this is the solution of first problem. Now we see here a second problem. Second problem is 1 plus 2i upon 1 minus 3i. This is the fifth problem, but we take here fifth problem and remaining second, third, fourth and sixth problem you solve yourself. Fifth problem, 1 plus 2i upon 1 minus 3i. 1 plus 2i upon 1 minus 3i. Call this as Z. So Z is equal to 1 plus 2i divided by 1 minus 3i. Again here it is the division of two complex number. In the denominator here complex number. So take its conjugate, multiply to numerator and denominator. So 1 plus 2i divided by 1 plus 3i. Here write 1 minus 3i as it is. Then take its conjugate, that is 1 plus 3i and divided by same 1 plus 3i. Now take the product of numerator divided by product of denominator. So we get 1 into 1, that is 1, plus 1 into 3i, 3i, plus 2i into 1, 2i, plus 2i into 3i, 2 3s are 6, I into I, that is I square. Now here 1 minus 3i and 1 plus 3i, again use here a minus b, a plus b, that is a square minus b square. So a here 1, so 1 square minus b square, b is here 3i, its square, 3 square is 9, I square. So Z is equal to 1 plus 3i plus 2i, that is 5i, and plus 6 into I square is minus 1 divided by Here 1 square is 1 minus 9 and I square is minus 1. So we get here Z is equal to 1 plus minus minus 6. 1 minus 6. 1 minus 6, that is minus 5. Plus this 5i. And divided by here 1 minus minus plus. Minus minus plus 9 into 1, 9. 1 plus 9, that is 10. And now divide this 10 to this real part and imaginary part separately. So we get here Z is equal to minus 5 upon 10. Minus 5 upon 10 plus 5 upon 10 into I. So Z is equal to, we get minus 1 half plus 1 half I. And compare it with A plus BI. And therefore we get A as minus 1 half. A is equal to minus 1 half. And B is equal to coefficient of I, it also 1 half. And now find R. R means mod of Z. R is equal to mod of Z. It is equal to under root of A square plus B square. So it is equal to under root of A means minus 1 half. Minus 1 half square plus B means 1 half, its square. So we get it as under root of 1 half square minus 1 half square, it is 1 by 4 plus here also 1 by 4. And so it is equal to, in the denominator here 4 is same, so 4 and 1 plus 1 2 upon 4. 2 upon 4. So 2 1s are 2, 2 1s are 2 and 2 2s are 4. So it is equal to under root of 1 by 2. This is R. Here we write, so R is equal to, R means mod of Z. It is equal to under root of 1 by 2. Under root of 1 is 1. So 1 upon under root of 2. This is R. Now we want to find theta. So theta is equal to, formula is tan inverse of B upon A. Then we write the formula of theta, then write where this point lies. Which point? This Z. Complex number Z is equal to, we get here minus 1 half plus 1 half I. So this complex number represent the point minus 1 half 1 half. Therefore point minus 1 half comma 1 half lies in which quadrant? Lies in, here x coordinate is negative, y coordinate is positive, so lies in second quadrant. In second quadrant. And therefore theta should be in the second quadrant. And therefore theta is equal to tan inverse of B. B means here 1 half. A is here minus 1 half. So theta is equal to 1 half get cancelled. So theta is equal to tan inverse of minus 1. Get it? So now carry this theta to left side, we get tan theta is equal to minus 1. Now tan theta is equal to this minus as it is, but we know that 1 is the value. 1 is the value for tan of which angle? 45 degree. 45 degree means pi by 4. So it is tan of pi by 4. But here see, left side is positive, right side is negative. So we have to remove this negative sign. We know that this point lies in second quadrant. So angle is in the second quadrant. And we know that in the second quadrant we take pi minus. In the second quadrant, here this is the second quadrant and here pi. So we take here pi minus. So pi minus which angle? This pi by 4. Then this negative sign get cancelled. So it is equal to tan of pi minus pi by 4. This is tan theta. So tan theta is equal to tan of 4 pi minus pi. Here 4 pi minus pi, that is equal to 3 pi by 4. 3 pi divided by 4. So tan theta is equal to tan of 3 pi by 4. So we get here theta. Therefore theta is equal to, see, theta is equal to, therefore theta is equal to 3 pi by 4. It tan get cancelled, so theta is equal to 3 pi by 4. So the polar form of Z, polar form of given complex number Z is given by Z is equal to R in the bracket cos theta plus I sin theta. So Z is equal to, put the value of R. R is here. R is 1 upon under root of 2. So 1 upon under root of 2 in the bracket cos of, put the value theta 3 pi by 4. 3 pi by 4 plus I sin of theta 3 pi by 4. So this is the required polar form. Highlight this solution. And exponential form. And exponential form is given by Z is equal to R into e to the power I theta. Put the value of R and theta. So Z is equal to, R is here 1 upon under root of 2 e to the power I, and put the value of theta 3 pi by 4. 3 pi by 4. So it is equal to 1 upon under root of 2 e to the power 3 pi by 4 into I. This is the exponential form. Highlight this solution like this. So we get here polar form and exponential form of the given complex number Z. So in question number 2 we have completed first problem and fifth problem. Remaining problem you solve yourself using this method, and in the next video lecture we continue the question number 5. So we stop here. Thank you.